We're going.
God.
Okay, in 5, 4, 3. Hello.
Hola.
Welcome to Pre-Calculus and another Steve Johnston class. And we are going to do 10-4 today on this, oh yes, the live studio audience. And we have all kinds of stuff going on today.
Like tornadoes?
Like tornadoes. All right. Anyway.
So if you don't see us next time, we got killed.
Yes. If you see us get sucked up out of the camera, then that's a tornado. Okay. So today we're going to do everybody's favorite topic, vocabulary. No, this is fun. No, this is good vocabulary. This is the kind of stuff that you will see for the rest of pre-calculus and calculus, and you will only see these words right here. These are all the words today. This will go all the way through college. Right? So, the only words you'll ever have to know with the first derivative test. Oh my gosh, this is the wrong one. Okay, let's see. Okay. That's so much better.
Yeah,
It is better.
No, I'm not laughing.
Why don't you just throw it away?
For tutoring.
Okay.
Because it's Expo
So,
3 marker.
Let's,
Marker tree.
oh yes, the marker tree right there. Challenge mystery.
What?
That's our challenge mystery.
Chalmers?
Yeah, it celebrates Challengemas. Which is, it's 22 days away. I'm not supposed to date it on the camera. I mean, it's coming soon, Challengemas. Coming soon to a household near you. Right?
Even though it has the date of being uploaded and shit.
I guess that's true, yeah. All right, so here's what we're going to do. Let's do a derivative first of all. Now, the derivative of this function, oh, Mr. Wade, why did you give us a 1/6? That's terrible.
Oh, that's
Well,
Oh, it works.
anybody try it yet?
Yes.
it. No.
Hey, guess what about those 6s?
Take it.
Did I
Okay, so nice. You cancel out, okay? Don't worry about that because it's nice cancellation. I mean, we're not doing the first derivative test right now, Tyler. We're just asking some questions though. So if you ever had to do a first derivative test in calculus, all right, we would do this. 20, what is that, 27x squared? Okay. So, so far so good. Okay, we're just following along over there. All the Steves and Stephanies. Is that really necessary? Okay.
Yes. Despicable
No,
Me.
not necessary.
Despicable Me is
Sorry,
the
it's
best
not
way.
necessary. Okay, now, okay, you can feel despicable when you're in office for a second. All right, now. Oh, is this a joke, Sue? Okay, this is a joke. There's your daughter right there. Okay, punish her later. Okay, now, on this right here, you have to factor out. Take out the greatest common factor, right? It always makes it easier. Let's take out an x squared. All right, when you take out the x squared, what's left over?
X cubed.
X cubed. Oh, wait a minute. Holy smokes. Hey, that was handcrafted. You're welcome. All right. Imagine if I give you x cubed minus 28. And you have to do the cube root of 28. You have to plug it back into the original function. Oh, you don't want to do that. No. So, Mr. Wade will give you some nice ones like this. And we'll set that equal to 0 as we always do. And it appears that x equals several things.
0 and 3.
0 and plus or minus 3 or just 3? Just 3 because of the odd power, right? Now if it's a squared or a fourth or a sixth, think about the plus or minus, right? Okay. Now, on the number line, which we will label so that we don't lose colossal points on the AP exam a year from now, right? Okay? Major deal, label it y prime. And on this derivative test, you will place the smallest number first. 0. And 3. Anybody at Independence or Raymond or Brentwood is watching this right now, no, we do not do derivatives in pre-calculus, I promise. Okay? This is just a fun day.
They watch it.
Just in case. Okay. All right.
1 million.
So, okay, how about a million?
You can just draw the arrow down.
There. All right. How about 1? 1. Okay.
Negative Google. Do it.
How about
Negative Google. Read out.
It's a thing.
okay.
Just point an arrow.
Okay. Now, let's take this and let's plug it in to this fabulous function right here, but I don't want to plug it into this one because then you have to work it out the long way. I want to plug it into the factored form because then you can just do the plus times a minus is a minus gain, and minus times a minus is a plus gain, and all that business. Okay? You can't can't do that, this is not the right line marker.
Jordan.
Oh my gosh.
You can see.
It's even worse.
They're all dead.
Where's?
And
There's
then-
another one.
I got this one down here, just put it down here.
Anyone
Oh,
like?
One more at the very end.
Well, I think this is the closest thing to it. I think it's just running out of time. Okay. All right. So let's do this. What is anything squared, by the way?
Positive.
Anything squared is negative. Google squared is a positive big number, right? You betcha. So the first group right there is always going to be plus. Okay? 1 squared, a million squared, everything squared is positive, right? There's only one thing squared that is not positive. 0 is the only thing squared that is not positive. However, it will be one of your critical numbers already, so it can't be a sample point, right? So all your sample points will give you plus, plus, and plus. All right, now let's do that second parentheses right there. All right, negative of Google, cube.
Negative. Yeah.
Negative gigantic, right?
Yeah.
Okay, it's got a negative on it, so it's actually very small. So, negative gigantic minus 27
Is that
is even more negative, okay? How about 1 cubed minus 27?
Negative.
Negative? Didn't go change there. How about a million cubed?
Positive.
Ooh, big number minus 27, yeah, really positive. Something peculiar about that there. It seems that the second parentheses didn't change to there, but it did change to there. I wonder why that is. Where did the change finally happen right there?
Because one,
That's
or
the
three.
wrong.
You know what? 3 is the root of that parentheses, isn't it? Ah, we just discovered something then. The only time you could ever possibly change your sign is if you went around the root. That's the only time. It didn't change around here because 0 is not the root of that parentheses right there. Okay? That's something you're going to notice in all these derivative tests. Now, sometimes you can get a false reading, like the x squared. If you have x squared, you get a plus plus back to back. Sometimes that happens. But if you ever do get a change, it has to happen around the root. Okay? So remember that one. Now, we get minus and plus. So this thing goes decrease, and then it does some more decreasing, and then goes back up again. So kind of like that. Okay? Now, let's look through the vocabulary words here and see if we can figure out what everything means.
Does it have to get to the point?
Well, it'll have to, all we know right now is decrease, decrease, increase. It doesn't have to touch these necessarily. Because it's not a graph of your position like the original function is. It's just a graph of your slope, basically. Yep. So you can just skip the point. All right. Now, let's see what we have here. Okay. First word of the day, which actually we've already discussed, is critical numbers.
Don't make fun of my breath.
Okay, now, critical numbers are where the function is what?
Neutral.
Okay, or I guess specifically where
Slope
the
equals
which
0.
Okay, the slope, otherwise known as the derivative, must be 0. That's all that matters. But Mr. Wade, I got a minus minus. It didn't even change the sign. Doesn't matter. It's still a critical number, right? So when does y prime equal 0? That's all you're thinking about right now. Okay. So if y prime equals 0 at what 2 places?
0.
0 and 3. So even if there's not a sign change, that's okay. They're both considered critical numbers. What if we got a number from the D and E case? Would we include that?
Yes.
If it is a critical number, it's only zeros, not D and E's. So if you got a D and E case, it's important, but it's not a critical number. Okay? So we wouldn't use it. Now, what about a relative minimum? Plural of minimum. We talked about that. Relative minima would be all of the valleys. Very good. So you basically have to account for all the valleys in the graph. Okay? All right. So to do that, let's do this. You see any valleys over here based off of this graph?
No.
You know what? Right there. Now here's the extra thing today. A relative minimum is a coordinate. Isn't that a point right there?
Yeah.
And so when you answer relative minima, you have to give a coordinate, okay? And you know one thing, the x-coordinate is what?
3.
3. But we don't know what the y-coordinate is.
Plug
okay?
it back.
You can plug it in. There's only one place in math where you get y-coordinates.
The original.
It's not the derivative. It's the original equation. Very good. Go back to the original, use that. You know what? It says right here, y-coordinate equals 1/6 of the x-coordinate to the 6th minus 9 times the x coordinate cubed. There it is. So that is a y coordinate, not a y prime, that's a slope. So go here, and let's use the top right-hand corner of the paper where we have some room up there if you want. And let's try to plug in 3 and see what we get. 1/6, 3 to the 6th minus 9 times 3 cubed. Okay? Mr. Wade, we don't have any calculators. You trying to kill us? 1/2.
Keep back
Okay?
out of
3 to the 6th, you must be out of your mind. Okay, well, let me tell you what we do all the time in calculus that is oh so helpful. Okay, yes indeed. It is. Very good. Okay, up here, what you want to do is there's always something in common. Take out something, even if it's not the greatest common factor.